Okay, looking at problem number 8. We didn't talk about absolute values in class, and you have an absolute value in equation number 2. Equation number 2 in this problem. You also have one in problem number 11. So we'll look at both of those, but first looking at number 8. Anytime you have something that you don't recognize in a function, y is greater than absolute value of x, you can always make a table. Look at equation number 2 first. Just set up values for x and y. Now you kind of have to guess which values of x you should pick. We'll always kind of start with -2, -1, 0, 1, and 2. Those won't always be the same, and we're going to show you how to graph absolute value functions later on. But now I'm going to take my absolute values and I'm going to plug them in for values of x. So I'm going to say y is equal to, I'm ignoring the inequality for right now, but I'm plugging in a -2 for x. The absolute value of a -2 is 2. The absolute value of a -1 is just 1. And same, so continue on, absolute value of 0 is 0. The absolute value of a positive number is just 1. Positive number 2 is just 2. These are going to go on our graph, and you'll see what shape an absolute value function takes. I'm going to plot -2, +2, -1, +1, 0, 0, 1, 1, and 2, 2. This is a dotted line function because it is greater than. It doesn't have the equality part. Now when I'm doing my shading, I'm going to shade the y values that are greater than the absolute value function. The y values above the function are bigger than the y values that are below the function, so I'm shading above the absolute value function. Second thing I'm going to do is go graph that y is less than 10. So we're going to go up to 10 in the y. And I'm going to draw my horizontal line at y equals 10. Again, it's a dotted line. Goes through the y-axis at 10. I'm shading all y values that are less than 10. So that's below. And I'm looking for the place where this graph is double shaded. It's double shaded above the absolute value function and below the horizontal line y equals 10. So my solution set is this area inside that V, but below the line y equals 10.